All right, today I'm going to be talking about lesson 7-1, improper integrals. So, the reason for the exclamation marks is this marks the beginning of BC only topics. Many people ask me, "Oh, Mr. Leven, can you keep giving us the BC equivalent of this assignment?" Unfortunately, from here on out, there are no BC equivalent assignments. Or AB equivalent assignments. There's only BC topics. What we're doing in Chapter 7 and Chapter 8 and Chapter 9 have no equivalent AB topics with which to give you the sheet. So you really need to be working on this on your own. I hope you are watching these videos soon, not just starting them in May. So, without further ado, improper integrals. You really have to have watched all of Unit 6 before coming to this unit. Most of the things on the homework will be review, and they're reviewing stuff in Unit 6. You definitely have to have learned the harder version of L'Hôpital's. That's not optional, and it seems like a lot of people are still struggling with that. Anyway. So, improper integrals. What will make an integral improper is if A, we can call this type 1, one or both of the limits of integration are infinite, or B, the function has an infinite discontinuity. What does that mean? A vertical asymptote at or between the limits. So, if we go right down the list, the type 1 should be easy to spot. Oh, this is improper, and this is improper. These both have infinite limits. And one of the things that makes BC hard are the other ones. Infinite limits aren't that bad. It's that from now on, whenever you see a definite integral, you have to be checking, oh, wait, is it defining the whole time? Because they can always sneak these in. So make sure you're checking, oh, when I plug in 1, it gives me a problem. It's like you could say a vertical asymptote at x equals 1. Okay? Which is a limit of integration. Bound. I think I use that word bound much more often. It's one of the bounds of the integral. Like bound. I don't want anyone getting confused. There's going to be some limits here. Bounds. Okay? Bounds, that's what it says. I know a lot of people can't read cursive. And this last one, again, the looks can be very, very deceiving. And from now on, you have to be worried about that. Very worried about that. Well, gee, this is undefined. The integrand is undefined at x equals -1, which is between the limits of integration, or the bounds. So between is the hardest one to see. It's very easy cognitively to just check plugging in the bounds, but to think about, oh no, it's a fraction, I better look at if it's definite. Oh, it's a definite integral of a fraction, I have to check. From now on, you have to check. And without further ado, here's what's going on. Just so it's clear, this blue guy corresponds to the first problem. The red guy corresponds to the second problem. This one doesn't have a picture. Okay? Although we could picture what it's supposed to be. No pun intended. Here we go. So let's start with the blue one. Here's how you need to evaluate it. Every single time you see an infinite integral, you need to know to write limit. Because it's in the top bound, I'm going to write b. Because we usually think about a to b. From 1 to b, I'll even rewrite the integrand. X to the negative 2 dx. So now I've said this improper integral can be written as a limit of these proper integrals. So let's do these proper integrals. Keep writing the limit every single time. Reverse power rule. Divide by the new power. Evaluate it from 1 to b. B going to infinity. Plug in the top bound. I would get negative 1 over b. Plug in the bottom bound. Plus 1. Now, some people will have trouble seeing how we got from here to here. B to the negative 1 is 1 over b. Okay. As b increases, this is going to 0. You need to know that. It seemed like this year a lot of people had trouble with that. That's going towards 0, so this limit's going towards 1. Okay? So this improper integral, we would say converged. It's no exaggeration to say all of Unit 7 and Unit 8 are about convergence and divergence. Alright. Problem 2, this integral. So again, my first step is to rewrite it with b. And we turn this improper integral into a limit of, I want to write this differently, into a limit of proper integrals. Now the reason I don't write this as x to the negative 1, I hope you all know x to the negative 1 is the only one that the power rule, the reverse power rule, doesn't work for. Instead, you need to know that this is the derivative of a very important function. This is the derivative of natural log. So its antiderivative is natural log. With the absolute value sign, please. So again, I keep writing the limit until I'm done evaluating it. Alright, really quick, what's natural log of 1? You said without 0, you're right. So this part's going away, but what's happening as natural log goes to infinity? As we move more and more to the right on a natural log graph, I'm increasing. This guy's going toward infinity. And we don't really say that. We would say this integral diverges. The infinity means it diverges, but it does not have a value of infinity. So that's really strange. So that's why I have these two pictures. In the blue picture, what we have going on is the area under the curve. All infinite of it has one value. There's only one unit of area below this curve, which is very, very strange. As opposed to here, this infinite integral also has only, as opposed to here, this infinite integral, there would be infinitely many area under the curve. There would be a infinite amount of area. I know I said infinitely many. That's very funny. Ha ha ha. Now, in some sense, and again, this unit is all about this. This is the key idea. This guy is getting small fast enough, and this guy is not. The only way to check that right now is to say, okay, let's take the integral and see what happens. Limit. Keep writing the limit. Alright, the first one without anything going on. Oh, infinity in the bounds? I better rewrite it. B goes to infinity. 0 to b. Cosine x dx. What's the antiderivative of cosine? Have you memorized it yet? You need to have. You might be watching these videos after we do it in class. I don't know, but you need to know it. Look how carefully I'm writing. Every single step is important. What's sine of 0? If you said without 0, good. Now, what's the limit as b approaches infinity of sine of b? This is a very important fact to know. When I do this in my BC class, the answers I get are 0. Nope. 1. No. -1. And I think this year we didn't have to say all three. Someone figured out, oh, wait, it doesn't exist. It does not exist, but I don't want you to write. I want you to write diverges for improper integrals. And again, it diverges because that limit doesn't exist. In case you're having trouble picturing why sine's limit doesn't exist, you know what sine looks like. As I go further and further out, this is not approaching one particular value. That's what limits mean. I need to approach one value as I go toward infinity. Alright. 2 mas. Alright, still improper, type 1, still improper, easy to see. Top bound, change it to a B. Oops, that's way too straight. One time I don't want to make a straight line, right? 1 to B. Now how can I integrate something like this? If you've been studying, if you've been watching the videos in the order I have asked you to, this should be clear to you now. Okay? Otherwise, you need to go back and rewatch some things in chapter 6. It's not exponential because the derivative of this guy's exponent is -1. I have to worry about the x. This is integration by parts, which you should always suspect when you see the product of two functions now, and there's not that relationship that you can easily check. Derivative, not that. So this is integration by parts. I want to make u equal to, and again, if you aren't having an easy time figuring what's supposed to be what, you haven't been ready, you aren't ready. U should be equal to x, the algebraic part, the polynomial part. Du would be dx. dv would be e to the negative x dx. And this is in some sense why BC is harder. There's plenty of kids in AB who have a hard time doing this integration, but will still pass, or even pass on with a high marks on the AB test. You guys have to know it like that. You have to be that quick with it. And then you have to know ultraviolet voodoo. I'm going to switch to green. So, that whole integral up there, with the limit, ultraviolet, write it like this, minus voodoo. And we talked about this when there's more and more steps. I talked about this in the video for integration by parts, which I think is 6-3. It might be good to rewatch that right now. Who knows? I don't know what kind of time you have. I talked about how it's nice to write your limits like this, to say we're evaluating the whole thing from 1 to b. The readers will understand what this means. Negative with a negative would be a positive, and then I'm going to integrate this again. Now, if you just watch the 6-3 video, like if you pause this video and watch that, and now are back watching this, you might be like, oh, couldn't you have done this with tabular method? Yeah, but tabular method's kind of overkill for this. 1 to b. And that should make sense. Again, negative with a negative, positive. But the integral of e to the negative x we just did is negative e to the negative x. Okay? I'm just going to keep going this way. Look how I'm writing the limit every single time. It's not an option. It's a non-negotiable. That's what they always tell us at admin meetings. It's a non-negotiable. You need to do it every single time. minus, with the parentheses, because we're plugging in the whole thing, negative e to the negative 1 minus e to the negative 1. Again, all you need to see is that this part, calm. The real question is what's going on over here. Now, again, you have not studied up on your limits enough if you don't know that as b goes to infinity, e to the negative b is going towards 0. Yes, it is. It's going towards 0. It's going to 0 incredibly quickly. I mean, negative infinity, e to the negative infinity. We're going to the real right-hand side of the graph of e, which is, of course, as horizontal asymptote at 0. So this part's calm. What about this part? What about this part? Well, let's just rewrite this. So again, maybe this will help you see more of what's going on. So negative b over e to the b minus minus 1 over e to the b. I know I'm way under here, sorry. Plus 2 over e. Really nice part. Okay? So, this part's definitely going to 0. Now, maybe with it rewritten, it's really easy for you to see. This part's going to 0. What about this part? So, if you think about like just plugging in just plugging in infinity, negative infinity over positive infinity. Oh, I should L'Hopital's it. That would be fine. That's a bit slow. For the BC test, you want to be fast enough to know, okay, this limit is going towards 0. Why? Because e is growing faster than any polynomial. That's at the end of lesson 6-6. You need to know it. I'll just close this out. Sorry. You need to know that fact. E is going faster than any polynomial. So this one's going to 0, this one's going to 0. So this improper integral converges to 2 over e. I wrote really big on this slide. I don't know why. Okay. When you watch that part, this is why Unit 7 and 8 are great. I can make you go over every single thing you've done in Unit 6 in one problem. Alright, so this integral. Again, many people have this instinct at this point, because you have learned calculus to a pretty good level. Oh, I'll just integrate it and evaluate it. But what you have to realize is this guy has a VA at x equals 0. So what do we do when there's a vertical asymptote at x equals 0? I'm going to rewrite this integral in this way. And this is the hardest part. This is something the BC kids get better practice with back in units 1, 2, 3, 4, 5. If it strikes you as challenging, it's okay. If I'm trying to find out the area between -1 and 2, I can get the area from -1 to 0, and then add the area from 0 to 2, right? That's just how integrals work. It's always okay to break it up into 2 parts. Now here I need to have two-sided limits. And that's what's really hard. Not two-sided, one-sided limits. You can lose points if you don't write this. So this is the top bound. I'm going to be going towards 0 from the left. The top should be a left. The bottom should be a right. I'll go over this again. It's going to make a lot more sense in a minute. These each are improper. So I'm writing them each as a limit of propers. I'm so sorry. It's not B. It's going to be A. Bottom bound, we call it A. That's just traditional. They don't really care what letter you call it. Just be consistent. A, B, B. So now I'll draw a picture, just in case you're having a hard time seeing this. As I get closer and closer and closer, like that. Yikes, nope. Something like that. Like that. Okay. So from the left. I'm going towards 0 from the left. I'm going towards 0 from the right, okay? That's what each of these halves are doing. Like, if I were to color this half pink, let's see if it's going to cooperate. Probably not. Nope. This pink part here, right? And this purple part, what we want to do is drag this side of the purple closer and closer to 0 from the left, this side of the pink closer and closer to 0 from the right. So that's why I have two integrals. Both of these integrals should be easy to do. Both of these integrals are power rules. So both of these integrals have the same inside. And both will be like this. X to the negative 3, x to the negative 2 over negative 2 from 1 to b. Plus x to the negative 2 over negative 2 from a to 2. Okay? I'm sorry, that should be a negative 1. Okay? Now we just plug in the bounds. B going to 0 for negative 1 over 2b squared plus 1 over 2 plus the limit as a goes to infinity, a goes to 0, sorry, not infinity, 2 to the negative 2, should get negative 1/8, plus, sorry, 1 over 2a squared. Because it's a minus and the minus makes that plus, okay? That's why they're both pluses and the minus out front, because they're both negative terms, okay? So now we're wondering where B is going. And here's was a hard part for Connell to accept. Connell likes to argue about these things. So Connell says, like, oh, well, you know, like, this guy is going toward negative infinity. This guy is going toward positive infinity. You know, it's going to cancel. No. And this is why you don't want to write this as one limit. This guy's going to infinity at some rate. This guy's going to infinity at another rate. They might not cancel. Okay? B squared and a squared are going to be different values as you do the limit. Okay? Unless you make them so, but that's not fair. So the idea is that if one part diverges, the whole thing diverges. Does this diverge? Yes. It's negative infinity plus 1/2. Diverges. Does this diverge? Yes. It's infinity minus 1/8. So the whole thing diverges. And that's it for 7-1. Improper integrals. You got some L'Hopital's. You got some integration by parts. You got some basic ones. Make sure you do the homework. Do not be watching these videos without doing the homework. You will not do well on the AP test. I guarantee it. Anyway, have a great rest of your day. Keep up the hard work. I really appreciate your work ethic. Bye-bye.